Alright guys, welcome back. In this video we are going to write a general function that calculates the integral of the function, and that function can be called in our main program at any time that is needed. So I'm going to define a function, say double. You're going to call, since you're using a trapezium rule, I'm going to name my function as trapeze, and this function we are going to pass some parameters. We have the function itself that we defined here up as a double f of x, double f of double x. Then we are going to add other variables, double a, so I have double b, and the int n. Then inside this function we are going to calculate the integral. So what you're going to do, we are going to copy this code that calculates the integral. Let's cut it and paste it in our function. So we are going to define to declare some variables that are not declared here. So you have double, have x, have h, we have sum, we initialize it to 0, a, b, n, they are already declared here. So we have int e. So that's all. So what you are going to do here, we are going to return the value of integral. You have to define integral here. Integral. So we say the return value of this function is our integral. So we come back here to our main program. We are going to define another variable here that we shall use to call our function. Let's call it a new integral. So you are going to use this variable, new integral. There's a problem with this variable name. Let's call it integ. Okay, so we have integ is equal to, so now there we are going to call this function trapeze that calculates the integral. is equal to trapez, and this function we are passing some values. We have f, we have a, we have b, and n. Have f, a, b, n. In fact, what this code does, it's going to take the value of a, which the user has put in here, the lower limit, and I assign it to a here. Then take the value of b and n, and these values will be used in our function here, trapez function, to calculate h, to calculate the sum, and calculate the integral. Then the function will return the integral. So when we are going to print the integral equals LF. So instead of integral, we are going to print the value of intake. So it's a intake. Okay, let's save, run our program and see how it works. Our limit is 0, upper limit is 1, number of subdivisions 3. Yeah, there we are. It was 0.351. So let's put that value here. So we are going to run again our program, and okay, let's comment this. Using a different number of intervals. So here we are going to 6, giving us the value 0.337. If we run our program again, for a number of intervals, say 18, so it's giving us 0.333. So as not to reduce the error, we increase the number of subdivisions. So when n is 3, we have 0.35. When n is 6, we have 0.33. When n is 18, we have 0.33 carrying. So when we integrate x squared from 0 to 1, we get the integral as x cubed over 3. So when you substitute in 1, so we find our actual value that you are supposed to get is 1 over 3, which is 0.33 carrying. So you can see as you increase the number of n, the value you get, the approximate value you get is closer to the actual value. Thank you guys for watching. See you in our next videos.